Help students to the homework help video, page 87. Let's go ahead and get started with the homework help video. Numbers 1 through, hold on one second, numbers 1 through 9, the directions say to find the domain and the range of the function. So for number 1, do understand that we are to assume there's no point here, so it continues this way. There's no point here, so it continues this way. So this graph will continue on and on to the left for the domain. It will continue on and on to the right for the domain. So the domain for this function would be negative infinity, positive infinity. Remember, you always use parentheses for infinity. Now the range is going to be the same, because as this continues to go right, it's also going to continue to go up and up and up and never stop. As this continues going to the left, it will continue going down, 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 and never stop. So the range is also going to be negative infinity to positive infinity. Okay. Alright, let's go ahead and take a look at number 3. Okay, now looking at the graph here, let's go ahead and come this way. We're going to assume it continues this way. So coming from the left, it's going to go on and on and on. So my domain would be negative infinity. And then it would come down, it would hit right here at 1 on the x-axis. So negative infinity to 1, and that would be inclusive, okay? Then it picks up, or negative 1, sorry about that. Then it picks up again at positive 1, and it would be inclusive, so bracket, and it continues on and on to the right. So that would be infinity, okay? Now the range definitely stops right here. It goes no lower than this, okay? As in terms of it stopping, going up, it won't. It'll continue going up, up, up. Now remember, when you write the range, just like with a domain, you start in the negative part or the left and work your way to the right. With a domain, you start with the negative numbers or the bottom and work your way up. So we can see that it's going to start at 0, and that's inclusive, okay? So this line goes to the y-axis at 0, and it's going to continue up to positive infinity with a parentheses, okay? There'll be no ceiling on this. It will continue on and on, okay? Alright, let's take a look here. I'm just checking my answers real quick here. Alright, let's continue on to number 5. Okay, now let's talk about the domain first of all, okay? As this goes down, it will continue going more and more to the left, and it will continue going more and more to the right. So the domain is going to be negative infinity to positive infinity. Now let's talk about the range, okay? The range is going to, this graph will continue going down, down, and down. So there's no bottom, okay? So we know it's going to be negative infinity. Now as it moves up, it stops right here at where on the y-axis? 1. And it is inclusive. So there we go. There's your range, okay? Alright, let me check my answer here real quick to make sure that we are correct. And we are moving on. Yes, that is correct. Okay, number 7. Let's see here. Okay, first of all, the domain, it stops here. It will not go any further to the left. So it stops here. It also stops here. It will not go any further to the right. So the domain is pretty obvious. It's going to run from negative 4 inclusive to positive 4 inclusive, okay? And we know it's inclusive because these points here are definitely colored in, okay? Alright, now let's talk about the range real quick. The range. Now the range, of course, is not going to go any lower than this line here. And it's not going to go any higher than this right here, okay? So, starting at the bottom, it looks like our range is going to run from 0 on the y-axis up to 4 on the y-axis, and both of those will be inclusive, okay? And I'm checking my answer. We are good. Let's continue on to number 9. Now, first of all, let's talk about the domain. The domain. Okay, it's going to continue to the left and continue to the right with no stopping anywhere in the middle. So we're simply going to have negative infinity to positive infinity. Now let's talk about the range. This is going to be really interesting. As you get used to graphs more and more, you learn to recognize things. Now, this is going to be an asymptote right here, okay? So even though it looks like the graph might eventually hit 0, or the x-axis, it never does, okay? So this line here that I'm drawing is as far as the graph goes, but it would be exclusive, or it would be non-inclusive inclusive, not inclusive, because this graph is getting closer and closer to the x-axis, but it's never going to touch it, okay? So your range is going to be 0 here at the y-axis, but do not put a bracket like this, okay? Put a parentheses because it's non-inclusive. Now, it goes all the way up to 1, and that will be inclusive because the graph actually goes to 1 right there, okay? So that would be the range, okay? So domain deals with the x values. The range deals with the y values. Okay, moving on to numbers 11, 13, and 15. The directions say to use the vertical line test to determine whether y is a function of x. So here we go. Is there anywhere you can draw a vertical line in which that line intersects the graph in more than one place? The answer is no. So it is yes, a function. Yes, it is. Number 13, is there anywhere you can draw a vertical line in which that vertical line will intersect the graph in more than one place? Well, yes, there's quite a few, okay? So, no, this is not a function. This graph does not represent a function, all right? Okay, moving on to number 15. Now, this one here is going to be really, really close, okay? But, to be honest with you, if you look at this graph is getting closer and closer to the y-axis, but it's never touching it. And this graph here going down is getting closer and closer to the y-axis, but never touching it. So what we have here, students, is a vertical asymptote going through here, okay? Like this. So, because of that, I don't care where you draw your vertical line, it will never intersect the graph in more than one place. And you might say, Mr. Harrod, if you draw it right here, it hits the graph over and over. To be honest with you, I know you can't see it, but the graph is gradually always moving to the left up here, or this graph here down here is gradually moving to the right. So every vertical line that you draw is going to intersect the graph only one time. And so, yes, this is definitely a function, alright? Okay, moving on to numbers 17 through 23. Find the zeros of the function by factoring. So let's go ahead and get after it. We're going to put a 0 here for f of x, and we're going to factor this, okay? It's a trinomial with a lead coefficient of 2. So 2 times negative 30 is negative 60. I need two numbers multiplied together. That will give you negative 60 when add together give you negative 7. Well, right away I think of positive 5 and negative 12. If you multiply those, you get negative 60. If you combine them, you get negative 7. So bring down your first term, bring down your last term, and right in the middle we're going to put these two numbers. So positive 5, and because there's an x right here, I'm going to put an x right here, and then minus 12x. Okay, pull out what's common in the first two terms. That would be an x. I'm going fast because we've learned this already. This should be review. Then over here, pull out what's common, which would be a 6. But because of the negative sign here, be sure and pull out negative 6. And you're left with 2x plus 5. Now we can check that real quick, okay? X times 2x is 2x squared. X times 5 is 5x. Negative 6 times 2x is negative 12x. Negative 6 times 5 is negative 30. So you write your matching parentheses once. And the other parentheses is x minus 6. Now this is pre-calc class, so I'm not going to do this for you. But now if you take each group and set each group equal to 0 and solve, here you'll get negative 2.5. And here you will get positive 6. So there's the two zeros, or the two x-intercepts, okay? Number 19. Alright, let's go ahead and look to factor this, okay? So first of all, up top here, students, I'm going to, well, I do know what to do. I'm trying to think of the easiest way to do this. First of all, I would multiply both sides by x to get rid of my fraction. So I'm going to multiply this side by x. And of course, there's a 0 right here. You put a 0 in for this. I would multiply this side by x. 0 times x is 0. Over here, 9x squared minus 4 over x times x over 1. Your x's cancel, leaving you with this. Okay, we're going to factor this. That's what the directions say to do. This is a perfect square. We know the square root of 9x squared. We know the square root of 4. So we're going to factor. And the square root of 9x squared is 3x. Put that here and here. The square root of 4 is a 2. Put a 2 here and a 2 here. Make one positive, make one negative, and there's the factorization. Now, if this had been a positive 4, remember you cannot factor the sum of two squares. You can only factor the difference of two squares, okay? Alright, well, if you take this group and set it equal to 0 and solve, you will get negative 2/3. And if you take this group here and set it equal to 0 and solve, you will get positive 2/3. Okay, so there's your zeros or your x-intercepts, positive negative 2/3. Number 21, let's go and put 0 in for f of x. Over here we're going to factor, pull out what's common, which would be an x. And actually, I'm trying to think if you could pull out a 1/2 also. We'll go ahead and pull out a 1/2 and an x and see what happens, okay? So we're left with x squared minus 4. Okay, let's see if that's right. 1/2 x times x squared is 1/2 x cubed, and 1/2 x times negative 4 is negative 2x. So that's correct. Now next, I can factor this because it's the difference of two squares. The square root of x cubed is x, so we'll put it here and here. The square root of 4 is 2, so we'll put it here and here. Make one positive, make one negative. Now, I have three groups. Any group that has an x is a group that I have to use to solve. So if I take 1/2 x and set it equal to 0, divide both sides by 1/2, x equals 0. If I take this group here and set it equal to 0 and solve, I will get negative 2. If I take this group here, set it equal to 0 and solve, I will get a positive 2. So there are the zeros or the x-intercepts of this function, okay? And that's number 21. Moving on to number 23. Okay, we'll put a 0 in right here. Now this is a 4-term polynomial. We're going to pull out what's common in the first two and pull out what's common in the second two terms. In the first two terms, they both have an x squared, so I'm left with x minus 4. Over here, 9 goes to both of these numbers. Because this first term here is negative, I'm going to plot a negative and plot a 9, and I'll be left with x minus 4. Now let's check and make sure, okay? X squared times x is x cubed. X squared times negative 4 is negative 4x squared. Negative 9 times x is negative 9x. Negative 9 times negative 4 is positive 36. So, write the matching parentheses once, and write the other parentheses with these two terms here, x squared, negative 9. Now, here's what's kind of funny. This group here can be factored again because we know the square root of x squared. We know the square root of 9, and there's a negative sign here. So now the factorization would be the square root of x squared is x, put 1 here and here. The square root of 9 is 3, put 1 here and here. Make one positive, make one negative. So x equals, take this group set equal to 0, 4. This group here would give you a negative 3. Take this group set equal to 0 and solve, and you'll get 3. So your answers would be 4, positive, negative 3. Okay, 4, positive, negative 3. Okay, moving on to numbers 25 through 29. The directions say to find the zeros of the function analytically. Verify your results graphically, okay? So here we go. Same thing again. I'm going to put a 0 here. And now I'm going to have 3 plus 5 over x. Okay, now I do not want this x here, so I'm going to multiply every term by x, okay? Or in other words, I'm going to multiply the entire equation by x over 1. X times 0 is 0. X times 3 is 3x. X over 1 times 5 over x is 5. Now bring the 5 over and make it negative because we're simply solving for x. Divide both sides by 3, and we're going to get negative 5/3 for your x-intercept or your 0, or you could also call it negative 1 and 2/3. Okay, moving on to number 27. Alright, now we're going to put a 0 in for f of x. And first of all, if we're going to put a 0 in for f of x and then solve for x, we're going to have to get rid of this radical. So I'm going to square this side to get rid of a square root. But if I square one side, I must square the other side. So if you square 0, you get 0. If you square a square root, you're left with the radicand. Bring the 11 over and make it a negative 11. Divide both sides by 2, and we get negative 11 over 2, or negative 5.5 for your x-intercept, or your 0. Okay? Alright, moving on to number 29. Okay, we're going to put a 0 in for this right here. Put a big 0 right here. Now, I don't want this fraction x minus 6, so I'm going to multiply both sides by x minus 6 over 1, okay? X minus 6 times 0 is just 0. Over here, your x minus 6 cancels with your x minus 6, leaving it with 3x squared minus 1, okay? Bring the 1 over and make it a positive 1. Divide both sides by 3. And now take the square root of both sides. The square root of 1/3 would be plus. Positive, negative, plus, minus 1/3. The square root of 1/3, and the square root of x squared is x. Now, we can split this up into positive, negative, square root of 1 over the square root of 3, okay? Now we know the square root of 1 is 1, so now we know the numerator is 1 over square root of 3. We're almost done, students. Now, we never want to have a radical in our denominator for a final answer, so we're going to rationalize and multiply the top and the bottom by the square root of 3, which we should be very good at doing from pre-calculus, and you will get square root of 3 over 3, positive, negative, for number 29. Okay? Alright, moving on to numbers 31 and 33. The directions say to determine the intervals over which the function is increasing, decreasing, or constant, and then determine whether the function is even, odd, or neither. Okay, now first of all, let's talk about increasing or decreasing. From the left to the right is always how you read a graph when it comes to decreasing and increasing. Well, it looks like to me it's increasing the entire time, and there's no boundaries to the right, there's no boundaries to the left, so it's increasing from negative infinity to positive infinity, okay? Now, moving on to the next question. Is it even, odd, or neither? Well, let's quickly review. An odd function means that it's symmetric to the origin. An even function means it's symmetric to the y-axis. Well, one thing we can take it to the bank on, we know it's not symmetric to the y-axis. If it was symmetric to the y-axis, you could fold the paper right here on the y-axis, and this line here should fall right on top of this line over here, and you can tell that's not going to happen. Now, if the graph looked like this, if the graph was V-shaped like this, then yes, when you folded this sheet of paper right on this y-axis, this line here would fall right on top of this line here. Thus, we would have y-axis symmetry, but that's not going to happen here. Well, the other thing we can do is we can fold it on the x-axis and then fold it on the y-axis, and that'll show us whether or not we have origin symmetry. For example, if I were to fold this piece of paper right here, this black line right here would then be right here. And then next, you fold the piece of paper right here on the y-axis, and this right here would fall right on top of this. So yes, it is an odd function, or in other words, it's symmetric to the origin. Here's another way to do it if you want to do it analytically. What you could do is take your given function, f of x equals 3 over 2x, where the f of x is put a y. Then everywhere there's a y, put a negative y. Everywhere there's an x, put a negative x. And a negative y is a negative y. 3/2 times negative x is negative 3/2 x. And then get y by itself by changing both the signs, or dividing by negative 1, and y equals 3/2 x. So, when I put a negative x in for x, and a negative y in for y, and I simplified, did I get out the exact same function I started with? Yes. So that means this function here, or this graph, is symmetric to the origin. Alright, number 33. Now let's first of all talk about increasing and decreasing, okay? First of all, we see it's going to increase. From here, it's going up from here to here. Now remember, when you hit this point here, I've taught you you're not going to use the y values, you're going to use the x values. values. So this point right here is even with what on the x-axis? 0. Okay, so we know the increasing is from negative infinity to 0. And by the way, we never use brackets when we're listing out increasing, decreasing, or constant, because you really don't know at this point here whether it's increasing or decreasing. Okay, now next, as we look here, we can see that we have a decrease from here to here, from here to here. Okay, now again, you use the x values. Okay, do not use the y values to get your intervals. So this point here is at 0 on the x-axis, and this point here is at 2 on the x-axis. So it is decreasing from here to here, and the interval, the decreasing interval would be 0, comma 2. Alright, okay, and then lastly, going from here to here, we have an increase, and it starts right at 2, so it's going to be positive 2, comma infinity. And wow, I've never seen a more beautiful infinity in my life. There we go. Okay, so to infinity. Let me check the answers real quick, like I always like to do, to make sure we're not making a little mistake somewhere, and then we'll continue on. Let's see what they're saying here. Increasing, decreasing. I think I'm on the wrong one here. Let's see. Decreasing 0 to increasing negative infinity 0 and 2 infinity. And then next they want us to decide whether this is even or odd or neither. Well, first of all, if you were to fold this graph right on the y-axis, would this graph here fold right on top of this graph over here? No, not at all. Okay. Well, if we were to fold it on the y-axis, okay, and then fold it on the x-axis, so fold it here. So the line would be here, like that, and then fold it on the x-axis. Would the two graphs fall directly on top of each other? The answer is no. And so this, guys, this function is neither even nor odd. If you want to try it analytically, you could put negative x's in for the x, and you will not get out the original equation. You can put a negative x and a negative y in, and you will not come out with the original equation. Okay, this function is neither even nor is it odd. Okay, all right, let's move on now to numbers 35 through 52, and the directions say to use a graphing utility to graph the function and visually determine the intervals where we're increasing, decreasing, or constant. Make a table of values to verify. So what we're going to do is this. On numbers 35 through, let's say 51, I believe it is, you only have to use a graphing calculator if you need to, okay? If you don't, then don't. In other words, if it's faster to graph it, then graph it. If it's faster to use a calculator, then use a calculator. For me, this is really fast. Y equals 3, so I'm going to have a horizontal line going through the y-axis at 3. So there's my line right there. So I just graphed f of x equals 3, okay? So it looks like to me it's constant. It's not increasing, it's not decreasing. So it's going to be constant from negative infinity to positive infinity. Alright, let me take a look at number 5 and make sure that's correct. Yes, that is correct. And that's sufficient for what we're going to do. Okay, number 39. This is one I'm probably going to use my graph run real quick just to make it easier. So I'm going to go to y equals and clear out my graph. I'm going to use x squared divided by 4. And then minus 1. And let's see what we get, okay? Okay, so I'm getting pretty much a parabola. It looks something like this, if you want to write this down. So it's going to be increasing from here. Excuse me, it's going to be decreasing, going left to right, going down. So it's going to be decreasing from negative infinity to this point right here where it hits right there. Now that's a low point, that's a minimum. So if I want to find this ordered pair, guys, come on, think about this. This is a turning point, so I know a minimum exists here. If the graph looked like this and the turning point was up here, that would be a maximum, okay? Well, we learned x value is this. The y value is this. Remember, what do you look at when you're writing increasing and decreasing intervals? You use the x numbers that it is decreasing from negative infinity to here, which is what on the x-axis? 0. And then it's increasing from here going up. So where's this point? Even to, or even with on the x-axis? 0. And it goes on to positive infinity. Okay, so there we go. Let's check the answer real quick. Make sure that we're doing well. And decreasing, negative infinity, 0, increasing, 0 to infinity. So yes, we're doing fine. Okay, moving on to number 43. All right, now, again, students, when you're allowed to use technology like crazy. So I'm grabbing my grapher. I'm going to clear that equation out. I'm going to hit x, and then second square root, and then 1 minus x, and then close the parentheses and hit graph. And let's see what we're getting here, students. Looks like we're getting kind of a graph that looks like this. Now learn to read your grapher, okay? It looks like it's something like this. Something like this. It's about right here, and it's going something up here, I can't really tell, and then curving down like this. Okay, so I've got to find out what it's doing up here. So I'm going to change my window. I'm going to focus on this point here. So I'm going to change my window to like 2, 2, negative 2, negative 2, so I can really zoom in on that. And that really helped a lot if you changed your window. If you changed your window so that you're at 2 here, 2 here, 2 here, and 2 here. How do you do that, Mr. Gerhard? Well, look at your top left button. Second one in says window. Push window, and then change your x minimum to negative 2, your x maximum to 2, your y minimum to negative 2, your y maximum to 2, and then hit graph. And you're going to see it does this. It's so helpful. It comes up here. It's right here, and it starts coming back down. It looks like it 1 right here. Okay, so it's increasing from here to here. So I've got to find that ordered pair, students. I've really got to find that ordered pair. Remember, that ordered pair right there is called a maximum point, because this is a turning point, and when you have a turning point, that point's either a minimum or a maximum. So I can find this ordered pair by using the maximum button on my calculator. So second calculation, option number 4, and then make sure you're all the way to the left before you hit enter, and then also to the right for the right bound before you hit enter, and then hit enter again. And let's see why it's not working here. Hold on a second. It should be working. Let's try this again. Okay, students, that time I got it to work, and I'm getting this for the ordered pair. 0.66666666, so it must be 2/3. And then 0.3849. Hold on 1 second, students. .385 will work just fine right here. 0.385. Now, this is your x value. This is your y value. Remember, when you're dealing with increasing and decreasing, you're going to use your x value. So it's going to be increasing. The graph is from negative infinity going all the way up to here, which is 2/3 on the x-axis. And it's going to be decreasing from 2/3 going down until it hits 1 right here on the x-axis, and that's where it's going to stop. Okay, all right, let's check the answers real quick there. Negative infinity to 2/3 and 2/3 to 1. So yes, that is correct. Number 47. I'm going to go ahead and use my grapher to help me. So let me clear out my y equation here, and let's put in, by the way, if you don't know where the cubed root is, let me help you, okay? I want you to go to math. It's the left column, third button from the top, far left column, third button from the top. Hit math, then look at option number 4 is cubed root, okay? So hit that, and then t minus 1 or x minus 1, and close your parentheses, and then hit graph. Now, So students, the graph looks something like this. I'm not going to be a perfect drawer here, but it looks like it's hitting one right here, so it's going to come up. This is what most cubed root graphs look like. They make a little curve like this, and they continue on. They do continue on in both directions. So if you'll look, it's just increasing all the way. I mean, from here to the left, it's going up, 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 continues to go up, continues to go up, and it looks like it's going to flat line a little bit here, but that's not true. The further out to the right you go, it will still continue to get higher and higher. So this graph is increasing from negative infinity to positive infinity because it never stops. Okay, that's all that it does is increase, and there's no boundaries to the left or to the right. So it's increasing from negative infinity, if I can get this pen to work, to positive infinity. Alright, number 51. Okay, this one here, I'll be honest with you guys, I think I can graph this one much faster than using the grapher. Watch this. I mean, this is just so simple, guys. Okay, x plus 3, do you see that? So I have y equals x plus 3. Now watch how fast this is. Y equals x plus 3, and the only values for x I can use are ones less than or equal to 0. So real quick, I'm just going to put in 0, negative 1, negative 2. There we go, it's so fast. So put a 0 in for x, you get out a 3. Put a negative 1 in, you get a 2. Put a negative 2 in, you get out a 1. So 0, 3. Negative 1, 2. Negative 2, 1. Now, the line's either going to look like this, or it's going to start here and go like this, or it's going to start here and go like this. One of those three scenarios. Or it could just go like this and stop in both ends. Here's what we're going to do. Notice it says x is less than 0. So that means we cannot go this way, because now you're getting into the territory of where x's are greater than 0, and the graph does not exist in that part because of this constraint right here, this inequality. So we're going to go from here, and we're going to draw it like this. There we go. That was very easy. Now look at this next one. The next one is y equals 3. Y equals 3. Well, students, that's a straight line, a straight horizontal line going through 3 on the y-axis, okay? But the only problem is we have to cut this line off. And you say, what do you mean, Mr. Hart, cut it off? Well, look, y equals 3 is only defined from 0 to positive 2. So from 0 right here, let me get out my eraser here. So this straight line here going up, the straight line, y equals 3, is only good from 0 to positive 2. So 1, 2. So from 0 to 2. So the line's got to stop right here, okay? And then lastly, we have y equals 2x minus 1. Y equals 2x minus 1. And the only thing we can use are values greater than 2. So I'm going to go ahead and put 2 in here, even though I'm not supposed to, because that'll show me where this graph goes right up until I get to 2. So I'm going to circle it to remind me that it's not defined, it's undefined, okay? But I'm still going to put 2 in, and then greater than 2, so we'll put 3 and 4 in. So we'll put a 2 in, you get out a 3. Put a 3 in, you get out a 5. Put a 4 in, you get out, and let's see, this will be a positive 5, and this should be a 7. Yes, 8 minus 1 is 7. So the first point is 2, 3, which is right here, so it's already colored in for us. The next point is 3, 5. So 3, 5, and the next one is 4, 7, which is right here. Now this line goes from, you're not going to draw it like this, and just connect the dots like you're used to doing from algebra. What you're going to do is you're going to look at your constraint here. X is greater than 2. So start this way and go this way like this. And it continues on. Okay, so this is really not too difficult. First of all, from here to here it's increasing. From here to here it's increasing. So we have an increase. And the increase runs from negative infinity to this point here. Now remember, what is that even with on the x-axis? Remember, you always use x value thing goes from negative infinity to 0, then it's constant from here to here. It's not increasing or decreasing. So I'm going to put constant from, now this point here is at 0 on the x-axis. This point is at 2, so it's constant from 0 to 2. Remember, you always use parentheses when you're dealing with increasing, decreasing, or constant. And then it's increasing again, so we'll put it up here. From here, which is equal to what number? On the x-axis, 2, all the way going up. So it's increasing 2, comma, infinity, 2, comma, infinity. Alright, let's take a look at number 51 and make sure that's correct. And yes, that is correct, okay? Alright, moving on now to numbers 53 through 57. We're going to use the graphing utility to graph the function and approximate its minimum, maximum points. So here we go. Go to your y equals and clear out your last equation. Parentheses x minus 4, parentheses x plus 2. And I'm getting a graph that looks something like this. The vertex is, it's about down here somewhere like this. It's a parabola looking like this, okay? So remember, maximum and minimum points only exist at turning points, and I only see one turning point. It's this one here, and that's going to be a minimum. Okay, so let's find that minimum point, okay? So here's what we're going to do. We're going to go to our calculators in a second if I can get this thing to work. There we go. We're going to go to our calculators. We've got this graph up on our screen, okay? So we're going to go to second calculations. That's top right, second button over to the left. So top right all the way up, top right corner. Then go one button over to the left, and that'll be the calculations. Scroll down to a minimum, okay? A minimum. And so the left bound, make sure when it asks for left bound, you stay right here to the left, and make sure when it asks for right bound, you stay over here to the right. And so here we go. There's the left bound, and there is the right bound, and then the enter for the guess part. And we are looking at, now guys, my calculator is saying point for the x value here, it's saying 0.9999999. So you can pretty much assume that's a 1. Sometimes it's 1 and your calculator will do stuff like that. And then my y is a -9, so 1, -9. So that's going to be a minimum point of 1, -9. Okay, let me check the answer key real quick to make sure that we are accurate. And we are, and we're going to move on. Alright, now number 57, be sure and enter this very carefully into your grapher, okay? So you're going to type in 2x arrow third power, and then minus 5x squared, and then minus 4x, and then minus 1, and then hit graph, okay? And if you do that correctly, it's going to look something like this. Now I have a standard window of over 10, up 10, down 10, okay? And the very bottom here is missing. It looks like it's coming up and hitting somewhere in here, and then coming down, and it goes off the screen like this. It goes off the screen and comes back up. So what that tells you is, students, and it should be common sense, you should understand this, what that tells you is you're going to have to make your y-axis a little longer at the bottom, okay? So you can see the whole graph that way, okay? So I'm going to go to my window, go ahead and push your window button, and I'm going to make my y minimum, instead of a -10, I'm going to make it a -15, and see if that's enough. Hit graph, and now let's see if we can see the entire graph. Yes, we can. We're totally good. So my first turning point is right here, okay? It's in green. Here's my first turning point. So I'm going to hit second calculations, and I'm going to go to maximum, because this is a maximum. This is a maximum turn right here. So option 4, and for left bound, make sure your cursor's over here somewhere. Then hit enter, and then make sure right bound, make sure your cursor's over here somewhere. Hit enter, and then enter again. And for this ordered pair right here, I'm getting -0.333335. So I'm going to put -1/3, comma, and then I'm getting -0.2962. So I'm going to put -0.3. Okay. Now I'm going to look at the answer book real quick and see if they have that also. yes, that's exactly what they have, so we're good so far. Now, the next turning point I see is down here somewhere. This is going to be, by the way, this is a maximum point. So you would label that a relative maximum. This is going to be a relative minimum. So let's go ahead and hit second, calculate again, then hit minimum, option 3, then left bound. So we're going to scroll and make sure you put your cursor somewhere in this area right here. Hit enter, and then for right bound, make sure you put your cursor somewhere over here. Hit enter, and then for gas, hit enter again, and they're going to give us for this ordered pair right here 2, -13, 2, -13. So this ordered pair here would be your what? Your relative minimum, because it's a low point down here. So there's your maximum, there's your minimum, okay? And by the way, there's no limit as to how many minimums or maximums you could have. It just all depends on how many turning points the graph takes, okay? Alright, number 61 through 65, the directions say to sketch the graph of the linear function, label the y-intercept. These are going to be pretty simple, guys. This is old school algebra 1, okay? Y equals -x minus 3/4. Now for me, very quickly, I'm going to put a 0 in for x to get out my y. I'm going to put a 0 in for y to get out my x-intercept. Bring the 3/4 over and make it positive. Divide by -1, there's your x-intercept, just like that, we know it, okay? So there's your x-intercept, -3/4. Now to find the y-intercept, put a 0 in for your x. So 0 minus 3/4 is -3/4, there's your y-intercept, okay? So here we go. We're going to go to -3/4. Here's -1, so we'll go to -3/4 for the y-intercept. The x-intercept, or this would be the x-intercept here, sorry. The y-intercept would be down here, -3/4. So the line would look something like this. Okay, so there's the graph of the line. And then the directions also say to label the y-intercept. Well, here's the y-intercept right here. So we're going to call that 0, -3/4. Okay, that would be the y-intercept. Let's check that very quickly in the book here, and it looks like we have that right. Moving on to number 65. Okay, same thing again very quickly. This really could be a y. So where the x is, I'm going to put a 0, so the y-intercept, if you put a 0 in for x, the y-intercept would be -1.8, okay? If you put a 0 in for y, you'll have 0 equals -1.8 plus 2.5x. Bring the 1 point over, make it positive 1.8. Divide both sides by 2.5, so 108, or 1.8. Divided by 2.5 would give you 0.72 exactly. So the x-intercept is 0.72. So here we go. Don't need a very big graph. The y-intercept is -1.8, so about right here. And the x-intercept is 0.72, so there's 1, so about right here. So there's the line. Not the best line, but hopefully you get the point. So taking a look at 75, there we go, that's exactly right. And it says to label the y-intercept. So your y-intercept right here would be -1.8. Okay, that's where the y-intercept would be. Alright, and of course I guess we really should put 0, 0, -1.8. Alright, okay, moving on to number 69. 69 and 73, the directions say to write the linear functions that has the indicated function values. Now, I didn't really go over this in your notes, but it's really pretty simple. Hopefully you remember how to do this. F of 5 equals -4 just means you have an ordered pair of 5, -4. F of -2 equals 17 means you have an ordered pair of -2, 17. Now, remember when you write a linear equation, the first thing you need is the slope. So y minus y, -4 minus 17, x minus x, 5 minus a -2. So I would get -21 over 7, which of course reduces to -3. So there's your slope right here, equals m equals -3. Now, next you want to find your b, or your y-intercept. Remember how to do that? We have a formula for that. Y equals mx plus b. Now, It doesn't matter which ordered pair you use. You can use this one in this formula or this one, but A, don't use them both, and B, don't mix them up. Don't take the x from here and the y from here, or don't take the y from here and the x from here. Pick one point and use it. Really doesn't matter which point, so I'm going to cross this off. I'm going to use this point here. So this is my x, this is my y, this is my m. So for the y, I put a -4. For my m, I put a -3. For my x, I put a 5. And then plus b. So now I'm going to solve for b. -4 equals -15 plus b. Bring the 15 over, make it a positive 15. 15 minus 4 is 11. So b equals 11. So do I know what the slope is? Yes. Do I know what b is? Yes. So you're ready to write your y, your linear equation. Y equals -3x. That's where your slope comes in. Plus 11. That's where your 11 comes in. So there's the linear equation, okay? Let me check that in the back of the book real quick to make sure that we're correct, and then we'll continue on. Y equals -3x plus 11. Yes, that is correct. Alright, number 73, same thing. So I have an ordered pair that's 1/2, comma, -6. And an ordered pair that's 4, -3. Alright, so my slope would be y minus y, -6 minus -3, x minus x, 1/2 minus 4. That's going to give me -3 over -3.5, or 3.5 would be the same thing as -7 over 2. Okay, so 1/2 minus 4 is -3.5, and -3.5 is -7 over 2. Now a negative over a negative is a positive, and we really have 3 over 1 divided by 7 over 2. So 3 over 1 divided by 7 over 2, or we could say 3 over 1 times, and flip this fraction, 2 sevens. 2 sevens, okay? So my slope would be 6 sevens. 3 times 2 is 6. 1 times 7 is 7. So the slope would be 6 sevens. Now, we have to find our b. So let's use our formula. Y equals mx plus b. And again, students, it really doesn't matter which ordered pair you use, this one or this one, okay? Either way is fine. I'm going to use 4, -3. So where the y is, I'm going to put -3. Where the m is, I'm going to put 6 sevens. Where the x is, I'm going to put 4, and then plus b, okay? So now I have -3 plus 24 over 7 plus b, okay? So 24 over 7 is 3 and 3/7, I believe. Yes, that is correct. 24 over 7 is the same thing as 3 and 3/7. So -3 plus 3 and 3/7 would just be 3/7. So b equals, hold on one second. I want to make sure I don't make a mistake. I think one thing I did wrong is this should be an equal sign here. Okay, there we go. So if we have -3 equals 33 over 7, bring the 3 and 3/7, bring the 3 and 3/7 over, and make it a -3 and 3/7. So you get -6 and 3/7. So b equals -6 and 3/7. So do we know what the slope is? Yes. Do we know what the y-intercept is? Yes. So you're ready to write your linear equation. Y equals 6/7 x minus 6 and 3/7. Okay, so there we go. That should be the linear equation we're looking for. Let me check. No, I'm getting, unfortunately, I'm getting a different answer in the back of the book, so I've probably made a mistake somewhere. Let's see if I can find it. No, that is actually the same answer. Instead of having 6 and 3/7, they have 45 over 7, which is the exact same thing as 6 and 3/7, so we're good. Moving on to number 75 through 81, I believe. Now 75 and 77, we're going to graph the greatest integer functions, okay? Now we did this one in your notes already, so to be honest with you, I probably should have given you a different problem, okay? But I didn't. So I'm going to say this: every time you put something in for x, you're going to go to the number that's to the left, okay? So we're going to start off with our table of values here, and we're going to put in So if you put in 1.2 into this box right here, it comes out a 1, and 1 minus 2 is negative 1. Let's try 1.4. Okay, 1.4 would be about right here, but you have to go to the left. So when you put in 1.4 into this greatest integer notation here, when you put in 1.4, you're going to get out a 1, and 1 minus 2 is negative 1, and so on and so forth. This will continue, students, all the way until you get to 2, and when you put 2 in for x, the greatest integer of 2 is 2, and 2 minus 2 is 0. But then look what happens. Any number you put in with 2, 2.1, 2.2, 2.4, 2.9, any number you put in for 2, 2 point any decimal will give you out 2 coming out of this box. If you put 2.1 in, it comes out 2. 2 minus 2 is 0. If you put it in 2.2, it comes out of the box 2. 2 minus 2 is 0. So we get a bunch of zeros for this. So what you're ending up with is this. Hopefully that's enough information to help you see what's going on here, okay? Alright. For your x values, 1 going up to 2. So from 1 to 2, we're going to be at negative 1. So look at it again. From 1 all the way going up to 2, we're going to be at negative 1. So from 1 all the way to 2, that's open point there, because 2 doesn't give you out negative 1. 2 gives you out 0. So from 1 to all the way to 2, you're going to be at negative 1. Now, from 2 all the way across, all your 2.1s, your 2.2s, all the way up to 3, you're going to get out zeros. So it's going to run from here to here, and that's open. So really from there, you don't need a lot more points. You know, the next one's going to start here, just follow the pattern, and it comes over here, and then follow the pattern this way. Next, we would have the step that starts here, goes over to here, okay? And the next one would be the step that starts here, and goes to right there, it's open point, and so on and so forth, okay? So there we go. I'm pretty sure that's correct. Let me check the answer book real quick. Yes, that is correct. Let's try number 77, okay? 77, let's start with the real easy number like 1, okay? It's going to be a little interesting. I've got to be really careful here. So here we go. Let's put in 1. Make this really long here, okay? We'll put in 1. 1 minus 1 is 0, and the greatest integer of 0 is 0, okay? Let's put in 1.4. 1.4 minus 1. Now be careful here. Think of a number line, okay? Let's get a number line up here so we can use that for a point of reference. Alright, negative 1, negative 2, negative 3, negative 4, 1, 2, 3, 4. Okay, now, when you put 1.4 into x, you first have to simplify. So 1.4 minus 1 is going to be 0.4. So if you're at 0.4 on the number line right here, 0.4, and then you go to the left, 0.4 is about right here, and go to the left, you'll get out 0 for your greatest integer. So 0. Let's try 1.9, okay? 1.9. Now 1.9 minus 1 is going to give you out 0.9, okay? So then you have to take the greatest integer of 0.9. Well, here's 0.9 right here, and I know it's really close to 1, but you always go to the left, okay? So, when you put in 1.9 in for x, you get 1.9 minus 1, which is 0.9, and you still have these integer brackets around it. The greatest integer of 0.9 is going to be 0 still yet, 0. So I think it's a little too premature to say we have a pattern, but let's just keep looking and see if we have a pattern, okay? I'm going to try 0. I'm going to go down and I'm going to try 0. 0 minus 1 is 1, and the greatest integer of 1 is negative 1. Okay, now I'm going to try 0.4 and then 0.9, okay? So I'm going to put 0.4 in, put 0.4 in for x right here, and 0.4 minus 1 is a negative 0.6, okay? So negative 0.6 is about right here. Then you always go to the left, so it's going to give you a negative 1. Now let's put 0.9 in for x. x. So here's 0.9 minus 6. That's going to give you, sorry about that, students. 0.9 minus 1 is going to give you a negative 0.1. Okay, negative 0.1, negative 1, and a positive 9, or 0.9 minus 1 is going to give you a negative 0.1. So where's negative 0.1 on my number line? Right here, because it's inside this box still. The greatest integer of negative 1, negative 0.1. So right here, go to the left, it's going to be negative 1, okay? So we're going to put a negative 1 right here. Now let's try one more. Let's try a 2, okay? Let's try a 2. So here we go. Put a 2 in for x. 2 minus 1 is 1. The greatest integer of 1 is 1. Let's put in a 2.4 and a 2.9. Okay, let's try a 2.4. 2.4 minus 1 is 1.4. So we have the greatest integer of 1.4. So let's go to 1.4 in the number line. Here's 1 and then 0.4, so we're about right here. Then you always go to the left, so it comes back to be 1. Okay. Now let's put 2.9 in very quickly. For the x here, we're going to put 2.9 minus 1 is going to give us a 1.9. Okay, so 1.9 is about right here. But then you always go to your left, the nearest integer going to the left. The nearest integer going to the left, that would be 1. So we'll put a 1 right here. So I think we've got enough now to see we've got a pretty, if not very standard pattern here. Alright, let me get a drink here real quick. And then we'll continue on. Now, first of all, for my graph here, for my x values going from 1 up to 2, it's going to be at 0. So on my x values going from 1 up to 2, so here's 1, 2, 3, okay. It doesn't matter if I put into this function 1 or 1.4 or 1.9, I get out 0. So at 1, I'm going to be at 0. And then continuing on, when I hit 2, though, it's going to be open. Alright, now for 2, look guys, anywhere from 2 to 2.4 to 2.9, so anywhere from 2 almost to 3, I'm going to be at 1, so I'm up here. Like that. Now here's another one. I did the 0, 0.4.9, so anything from 0 going to 1 is going to be at negative 1, so here's negative 1. It's going to run from here over to here and then there. Okay, and that pattern continues. Let me check the answer book real quick to make sure we're right, but that looks right. Yes, that's exactly right. And of course the pattern could continue upward or downward. That's totally sufficient. Okay, alright, number 79, we are to graph the function, so let's go ahead and get started with that. Number 79, I have y equals 2x plus 3. And the only values I can use are x less than 0. Now, even though it says less than 0, students, you still put 0 in and circle that point, so you remember that's going to be a hole in the graph that looks like that, okay? Alright, let's go and put 0 in for this function here, y equals 2x plus 3. The values you can use for x have to be less than 0. Right here, x is less than 0, so 0, negative 1, negative 2. So let's quickly plot those points. Put a 0 in for x, and you get out a 3. Put a negative 1 in for x, you get out a 1. Put a negative 2 in for x, you get out a negative 1. So let's see what we got here so far. So 0, 3 is 1 point, but notice it's an open point. Then negative 1, 1. And then negative 2, negative 1. So there we go. Now students, listen to me. Look at the domain here for this graph that you just did. It's x is less than 0. X is less than 0. So your x values cannot be over here. So you do not want to put the graph like this. You don't want to hit the point here and then keep going like that, because then you're over equals 3 minus x. The only values I can use are values greater than 0. Your x values have to be greater than or equal to 0. So I'm going to start at 0 and then go to 1 and 2. Put a 0 in for x, get 3. Put a 1 in for x, get out a 2. Put a 2 in for x and get out a 1. So 0, 3. So now it looks like this point gets shaded in. It was open, but now according to this part of the graph, it's defined. So 0, 3, and then 1, 2, and then 2, 1. And so of course it starts here and goes this direction like this, okay? Not a perfect line like it should be, but you get the idea. So there's the graph. This is called a piecewise function because it comes in pieces. Okay, there's more than one piece to this graph. Alright, number 81. This will be fun. Okay, we're going to enjoy this one. This will be interesting. Y equals x squared plus 5. And of course you have to use values less than 1. Okay. Now first of all, I'm going to appeal to your common senses, okay? We know a squared quadratic type of function, y equals x squared plus 5, is going to give me a parabola. But since they're putting constraints on it, it might be a half a parabola, or it might just be the bottom part that looks like this, okay? We just don't know. But when we go to graph this, it should have some parabola shape to it, okay? Alright, here we go. We have to use values that are less than or equal to 1. So 1, 0, negative 1, negative 2. That's plenty. We don't need that many, but real quick, 1, that'd be a 6, 0, that'd be a 5, that'd be a 6 again, negative 2, that'd be 9, negative 3 would be 14. That's good enough. We probably don't need these last two. I'll go ahead and do this one, be 21. We probably don't need these right here, but there they are in case we do. Now, let's go ahead and look at our next function, which is y equals negative x squared plus 4x. Plus 3. Okay, now I'm going to give you a little tip here, guys, or a little hint. Use your graphing calculator all that you want to, okay? I mean, use it like crazy. There's nothing wrong with that. So that's what I'm going to do. I'm going to get my graphing calculator all set up. And let's see. What I'm doing, students, is I'm entering this into my y equals graphing part of the calculator, so I can then use my table of values. You don't have to do that. You can put in each value as you want to. That's totally fine. However you want to do that's up to you, okay? But we're going to start at x is greater than 1, so we're going to put a 1 in. We're going to circle it to remind us there's a hole in the graph there, okay? So we're going to put 1 in and then go greater than 1, so your x values have to be greater than 1. So 2, 3, 4, 5, 6. So with my graphing calculator very quickly here, let's see what I have. 1 gives me out a 6, 2 gives me out a 7, 3 gives me out a 6, 4 gives me out a 3, 5 is a negative 2, and 6 is a negative 9. So that helps me a little bit with drawing my coordinate plane. My x values run from negative 4 to positive 6, and my y values run all the way to 21. I probably won't need these bottom two here, but my y values go from a positive 9 all the way to a negative 9. So we're looking at what is going to go 9 all the way around, okay? Looks pretty good. And we're just not going to have enough room, are we? Okay, let's go ahead and we're going to graph this one here in black. So 1, 6, 1, 2, 3, 4, 5, 5, 6, there's a 1, 6, and then 0, 5, and then negative 1, 6. And then negative 2, 9, so 6, 7, 8, 9. Now, how do I know which point? Do I start here and go like this? Do I start here and go like this? Well, look, what's your first point in your table of values? 1, 6. So you start there and go the other direction. So we've got a little bit, about half, a little more than half of a parabola. Okay, now I'm going to graph this part here in blue. Okay. So, no, this was my fault, guys. This was supposed to be it. No, that's right. It was a closed point. Okay, now this is an open point here. Remember, I circled this. Really, we weren't supposed to use 1 here. Look, x is greater than 1, not equal to 1. But I went ahead and put 1 here and circled it to remind us there'd be a hole. But when I go over to 1, 6 to put a hole there, the graph's already defined, so it's okay to leave it where it is. It's fine. Next is 2, 7. Next is 3, 6, so over to 3 and back down to 6, and then 4, 3, so 1, 2, 3, over to 4, 4, 3, and then 5, negative 2 is good enough, about right there. So the blue part picks up here. And by the way, how do you know where to start? What's your first point in your table of your values? Table of values 1, 6. So you start there, go up, and then come down like this. Okay, and there we go. So that's a second degree piecewise function. Pretty cool, okay? Alright, moving on to numbers 83, 87, and 91, I believe. Graph the function and determine the intervals for which your function is greater than 0. So we're going to graph this and then determine the intervals for which the function is greater than 0. So here we go. Y equals 4 minus x. Well, first of all, students, you should recognize this immediately as a linear equation, okay? So I love doing x and y intercepts. For the x-intercept, I'm going to put a 0 in for y, put a 0 in for y, bring the 4 over and make it a negative 4. You have negative 4 equals negative x. So divide by negative 1, 4 equals x. Now, let's put a 0 in for x, okay? And of course, 4 minus 0 is 4, so the y-intercept will also be 4. So there's my quick graph, positive 4, negative 4, okay? 1, 2, 3, 4, 1, 2, 3, 4. Y-intercept, x-intercept, and then draw the line. Now, students, moving on, the directions we've graphed this, that's really good. Now, the directions say, determine the intervals for which, it says this, f of x is greater than or equal to 0. Now, remember, f of x is also y, so you're looking for the interval where the y part of the graph is greater than 0. Well, guys, that means it can't be down here, because this part of the graph here is below the origin, and that means you're into the what part of the y-axis right here, the negative part. So when it says find the part of the graph that's y is greater than 0, it just simply means you want to be above the origin. So what part of the graph is above the origin? Here's the origin. Well, this part is from here. And it doesn't say just greater than 0. It says equal to 0 too. So we know how to do this. The interval would be, think about it, guys. The interval would be, we're coming from the left, so negative infinity. You always use the x values. So it hits right here at the y-axis at where? 4. And it's inclusive because it says where is y greater than or equal to 0. So there you go. The graph is above the origin from negative infinity to 4. Let's go over that again. F of x is greater than 0. That's the same thing as y is greater than 0. So what part of the graph has your y values greater than 0? Well, all of these ordered pairs here have y values that are positive. When you get down to these ordered pairs here, it's going to be like 5, negative 1. Well, look at that. Your y value is negative. You don't want any part of the graph in which the y values are negative. So this part of the graph from here all the way up, all of your y values are positive, which is what you want. Y is greater than 0. Let's take a look at number 87. Alright, this will be interesting. interesting. I'm going to encourage you to use a grapher on this one, although really you don't have to. This will be kind of like a parabola, but I'm going to go ahead and use a grapher real quick. So 1 minus x to the 4th power. And you can pretty much be in your standard window, more than likely, I would assume. And you should be pretty good. And my calculator is frozen up like it does so many times. This thing is literally held together by tape and glue and everything else. Alright, let's try this again real quick here. Okay, I'm getting something like this on the graph. Okay, it looks something like this. It comes up. It doesn't do that, that's for sure. It comes up, it's about right here, and comes back down. Okay, now, here's the deal. Now listen to me, students, please. We have to know, remember the graph is above the origin or above the y-axis from here to here, is it not? So I have to know what these two ordered pairs are. Okay? Now, there's a way to do that. And if you'll listen to me, I will teach you how to find those ordered pairs. So please listen to me carefully. Okay? Here we go. Remember, these are called x-intercepts or zeros. So if you've not entered this into your grapher, go ahead and enter it into your grapher. Make sure you're on your standard window, and then hit graph and get the graph on the screen. After you've done that, I want you to go to calculations. That's the top row of buttons. Second one from the right, it says trace on it. Hit second calculations, and notice option 2 is zeros. So hit enter on option 2. Now, I think I hit the wrong one, so hold on 1 second. Okay, now it's going to say left bound. We're looking for this 0 first, so make sure you're over here somewhere with your cursor to the left of that. So I'm going to do that too. Scroll over, make sure you're to the left now. Hit enter. Then it's going to say right bound. So you want to move somewhere in here, which is to the right of that x-intercept. And hit enter. Then guess, hit enter again. And mine says -1, 0. So this ordered pair is -1, 0. Okay? Now, let's go ahead and find this x-intercept here. So go ahead and hit second calculate. Go to option 2 for zeros. It's going to say left bound. So you want to be to the left of this ordered pair. So be somewhere in here. Kind of close to it, but to the left of it too. And hit enter. Now it says right bound, so be over here to the right of it, okay? Hit enter. And then enter again. And you're going to get 1, 0. So this ordered pair is 1, 0. So the part of this graph that's greater than 0 is going to be from here all the way up to, this is -1, and this is 1. So it's going to run from -1 to +1. That part of the graph is greater than your y values are greater than 0. So the interval would be -1, comma 1. Okay, let me check the book real quick and make sure that we are accurate on that. Yes, we are. And now let's move on to our last problem, and we're finally done. Number 91. Okay, number 91 I think is just a flat fraction. Excuse me, a flat graph. So pretty simple, to be honest with you. Look at this. Y equals -5. So we're going to draw a horizontal line through -5. 1, 2, 3, 4, 5. I'll do it in green here. So here's my horizontal line going through -5 like this. There it is. Isn't that easy? Now I have a question for you. Is any part of this graph above the y-axis? No. All of these ordered pairs will have negative y values. It would be like 2, -5. Over here it would be -5, -5. All of your y values on this green line are going to be negative. So, what is the interval for which y or f of x is greater than or equal to 0? There is none. It does not exist. There is no interval where your y values are greater than or equal to 0. So you would say, the answers in the book simply says that all of your values, f of x is less than 0 for all of x. I would I would simply write there are no values for f of x greater than 0 or equal to 0. There's none. Okay? I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.